I apologize for that. I had received a call, had to take that. But just as I was saying, the easiest way to solve this is to first of all FOIL it out. So 3x minus 1 times 3x minus 1 will give us this. We're now going to integrate this just like the previous example we had done earlier. We're going to take the integral of each part separately. So first we do power rule. So we add 1 to the exponent, divide by that new exponent. So that'll be 9x cubed divided by 3 minus 6x squared divided by 2 plus 1x plus c. Well, we can simplify that to be 3x cubed minus 3x squared plus x plus c. And that would be it. Next example. Here we can simplify by dividing each of them out to all three terms. So x squared divided by x to the 5th becomes, and then I'm going to send it back up. So that'll be x to the negative 3rd. 4x divided by x to the 5th becomes plus 4x to the negative 4th. And then, of course, plus 5x to the negative 5th. Now I'm going to integrate each of these. So I add 1. So that gives me negative 2. Divide by that new exponent. Plus 4x to the negative 3. Divide by that new exponent. Plus 5x to the negative 4. Divide by that exponent. And of course, plus our constant. We're going to simplify it to send all our negative exponents to the bottom. So that'll give us negative 1/2 x squared minus 4/3 x cubed minus 5/4 x to the 4th and plus c. This last example, of course with the trig, the easiest thing we got to do first is take out this constant of a fraction that we have, and then we'll be able to integrate it. So 3/2 the integral of cosine theta d theta. The integral of cosine is sine theta plus some constant, and of course with our 3/2 in the front. And that would be it. I've got some more examples. Easiest way to do this part is FOIL the top, change your radical into a fraction exponent, and then simplify it throughout. So the FOILed part on top would be 6x squared minus x minus 12 divided by x to the 1/2. Apologize for that. And then we're going to take 1/2 into every term on top. So that'll give us 6x to the 3/2 minus x to the 1/2 minus 12x to the negative 1/2. Then we would integrate this. Which would then give us 12x to the 5/2 divided by 5. This is already the simplified version. Minus 2/3 x to the 3/2 minus 24 x to the 1/2, and of course plus our constant. for example E, let's divide it into two fractions and see where we can go from there. So we'll have sine of x over cos x times 1 over cos x. Well, we know that sine over cosine is tangent and 1 over cosine is secant. So if we rewrite those, we've got tan x secant x dx. If you look at your formula chart, or you should remember, tan x secant x is the derivative of what function? And that goes back to secant x, since we took the integral, plus c. For example F, we're going to split it up into two integrals and pull out the constants from each. So it'll be 5 integral, I'm going to already rewrite it, of x to the 1/3 minus 2 integral e to the x dx. For the first part, I'm going to use power rule, so that'll give me 5 times, I'm going to add 1, so that'll give me x to the 4/3 divided by 4/3 minus 2, hold on, before we do that, since we're separating them into two integrals, plus our first constant, minus 2, the integral of e to the x, just like its derivative, is just e to the x, plus our second constant. Well, we're going to simplify this, and we're going to say that C3 is just some constant, and that's made up of the very first constant plus the second constant, so that we don't have too many constants in our final answer. Simplifying it would give us 15/4 x to the 4/3 minus 2e to the x plus C3. The last part is talking about solving differential equations. This is the very beginnings of differential equations. We are going to get through them, but not into too much detail just yet. So it says, in example 1, we explored a simple differential equation, a DEQ, of the form dy dx is equal to 2x. So a differential equation is just a statement about the derivative of y with respect to y. We found a family of functions that had the same derivative. This antiderivative is the general solution, but now our goal is to solve for y with a specific solution for the constant of integration, which is our plus c, based on the initial condition that can be used to find c. So looking at this very first example, or these 4 examples, solve the differential equations subject to the given conditions, or the initial condition as it's known as. You're given that the derivative is equal to 2x minus 1, and the initial condition of f of 2 is equal to 5. So we're going to rewrite it with a dy dx, because we know that that's another notation for derivative. We're going to send dx to the other side so that dy is by itself and all the x variables are together. At this point, since we're trying to solve for y, we're going to take the integral of both sides. Because if you recall, integrals and derivatives are inverses of each other, so they will undo each other. So the integral of dy is just y equals, and then we take the integral of this side, which would be 2x cubed over 3 minus 1x plus c. Given that we're looking for an equation, we have to use our initial condition of 2 and 5. We know that 2 is our x and 5 is our y. We substitute them in and solve for c. So 5 equals 2 times 2 cubed over 3 minus 1 times 2 plus c. So that's 8 times 2, 16 divided by 3 minus 2. Did I do this? Yes. So, probably gonna need a calculator at this point. You would solve for c, so then your final answer would be, let me write it out here off to the side. Y equals 2x cubed over 3 minus x plus whatever value we got for c. But given that it's a fraction, we need a calculator, so let's move on to another example. One with trig. So very first part we got to do is rewrite it. So dy dx equals 2 cos x. dy equals 2 cos x dx. Integrate both sides. Y equals negative 2 sine x plus c. Substitute in our values. So negative 3 equals negative 2 sine of pi over 2 plus c. This one should be easy since we should know our unit circle. Sine of pi over 2 is 1 times negative 2 is negative 2 plus c is equal to negative 3. We add 2 to both sides, so c is negative 1. So our equation here would be y equals, the integral of cosine is a positive sign, so then we should be subtracting 2, which would actually give us a negative 5. So it's y equals 2 sine x minus 5. Know my unit circle, but not so much my integrals. Okay, next example. I'm simply going to rewrite it at this point already. So dy equals x squared plus x minus 7 dx. We're going to integrate both sides. That'll give us y is equal to x cubed over 3 plus x squared over 2 minus 7x plus c. 1 equals 3 cubed over 3 plus 3 squared over 2 minus 7 times 3 plus c. Which gives us 27 over 3, which is 9, plus 9 halves minus 21 plus c is equal to 1. Using a calculator, we would get c is equal to 17 halves. And then our final equation would be y equals x cubed over 3 plus x squared over 2 minus 7x plus 17 halves. Last example. Y equals 3x cubed over 3 minus 4x squared over 2 plus 2x. I just automatically took the integral of the right side. And of course, plus c. We substitute in our values. So our initial condition, negative 4 equals negative 1 cubed, because I can simplify at this point, minus 2 times negative 1 squared, plus 2 times negative 1, plus c. Simplifying all this and solving for c will give us a value of c equal to 1. So our final equation will be y equals x cubed minus 2x squared plus 2x plus 1. Hope this video helped you understand at least the beginnings of antiderivatives and the indefinite integral. Thank you.